So good morning my dear students. Today we are going to discuss about a very important concept, that is mutual inductance. Transformers and induction machines are works based upon this basic principle, that is mutual inductance. That is mutual inductance. What is this mutual inductance? Now we will discuss clearly. So here let us consider two coils L1 and L2 are placed side by side each other. See here, man. Let us consider two coils L1 and L2 are placed side by side each other as shown in figure. See here, this is one coil and this is another coil. These are placed side by side each other. So now if we can consider, let N1 be the number of turns in coil 1. So this is coil 1 L1 and N2 be the number of turns in coil 2. This is coil 2. So now whenever we have to excite any one of the coil here, for example, we have to excite the first coil with a source voltage V1. So with this excitation, the current flows to the first coil is I1. That means let I1 be the current flowing through the coil 1. So now the next coil, that is L2, is excitation free. That means we did not given any excitation for the second coil. Then what happened here? So here the current I1 in the first coil produces a flux. That means whenever a current flows through the conductor, which can produces magnetic field, that magnetic field means which is due to the magnetic flux around the coil. So that means the current I1 can produces a flux phi1, and this flux can also links with the number of turns of coil 2. That means here the flux linkages are developed in the coil 2. Even though we are not given any supply or any excitation for the coil 2, if there is no current flows through the coil 2, the flux can be produced in a coil 2 and flux linkages are formed in the second coil due to the flux produced by the coil 1 or due to the current flowing through the coil 1. Then we will said the two coils are coupled coils, and those two coils are mutual coupling. and at the same time those are also called as, those two coils are inductively coupled, those two coils are inductively coupled, and the circuits, the two circuits L1 and L2 are called coupled circuit, and this phenomenon is called mutual inductance. Now see here, so here, due to the current I1, the flux can be produced not only in the coil 1 here. This is the flux produced in the coil 1. And this flux can also links with the coil 2. This phenomenon is called mutual inductance here. This phenomenon is also called mutual inductance. Now we will see the flux linkages in coil 2 is lambda is equal to. So here the flux can be linking in the coil 2, that is N2, and what flux can be linked in the coil 2? The first coil flux, that's why phi 1, and this flux is due to the first coil current I1 here. So this is the flux linkages. Then for the basic definition, the mutual inductance between two coils is given by M12 is equal to, we have the basic formula, flux linkages per unit current here. The flux linkages are lambda by unit current, means here flux linkages are produced due to the primary coil current, then lambda by I1. So then substituting equation 1 in equation 2, we get M12 is equal, this is the mutual inductance between coil 1 and coil 2, then it is N2 phi 1 divided by I1, which is equation number 3. Units are henries. So now how to define this mutual inductance? Definition. So see here, the self-inductance means the flux linkages per unit current. That means here the flux linkages are due to the one coil current, but mutual inductance means the flux linkages in a coil per unit neighboring coil current, is called mutual inductance. The flux linkages of a coil per unit neighboring coil current is called mutual inductance. Then what is mean by definition? What is the meaning of self-inductance? What is the definition of self-inductance? The flux linkage of a coil per its own coil current is called self-inductance. We are already defined. Here mutual inductance means the flux linkage of a coil per unit neighboring coil current is called mutual inductance. The expression is M1. If for example the excitation is interchanged, that means the excitation is provided for the coil 2 and the first coil is excitation free. Then what happened? The excitation for the second coil, the current flows through the coil 2 is I2. This I2 can produce flux in the L2. This flux can also linking with the first coil. This phenomenon is called mutual induction. Why? Because of it is induction means here there is no conductival connection between coil L1 and coil L2. Without electrical connection between the coils, the magnetic energy can flow through coil 1 to coil 2. That's why it is called mutual inductance. So now see here, when coil 2 is excited, the current flows through coil 2 is I2, which can establish a flux phi 2 in coil 2, which can also links with the first coil number of turns. Then the flux linkages in first coil due to I2 current is lambda 21 is equal to, in previous case that is lambda 12, but here it is lambda 21. That means the first coil number of turns into the flux is due to the secondary coil, and the flux linkages are due to the secondary coil current here. So now which is the continuation equation number 4. Now the mutual inductance M21 is equal to lambda 21 by, here lambda 21 is the flux linkages in coil 1, that is N1 phi 2, and here mutual inductance is lambda 21 by I2. This is the definition for mutual inductance, the flux linkages per unit current. So then now this is the M21, that is lambda 21 is equal to I2, and here it is M12 is equal to lambda 12 here, lambda 12. So now see here lambda 21 is equal to, substituting equation 4 in equation 5, we get M21 is equal to N1 phi 2 by I2. Equation number 6, which is in Henry's. If the circuit is a linear one, the magnetic circuit is a linear one. That means if there is no ferromagnetic material in that magnetic field, M12 is equal to M21 is equal to M. That means the mutual inductance between coil 1 and coil 2, and the mutual inductance between coil 2 and coil 1 is equal to same. That means the flux produced by the current 1 as well as flux produced by the current 2, and the flux linkages due to current 1, the flux linkages due to current 2, both are same. If the circuit is linear circuit, this is the concept of mutual inductance. Based on this particular concept, the transformer can produce EMF in secondary coil. That's why which can gives the effects of step up the voltage, step down the voltage. In case of mutual inductance, the flux can be induced in the rotor circuit. Due to this mutual induction, then torque is produced. Then finally it can produce the mechanical energy.